Okay, this is for our organic chemistry test 7 and 8. So first we're going to start off with our halo generations. You can remember with our halo generations we have multiple generations. So just how you have multiple generations, you have two here. You're always going to add two things, okay? So open up the one arm, open up the left arm, add a chlorine, add a chlorine. This would be chlorination. This could be Br2, which would be boronation. This is showing the kind of the mechanism. If there is a cyclic cycle, this is how the reaction is going to work. It's going to grab like this, okay? Obviously, it's not going to grab like that up here, but it will grab like that here in that circle. Moving on down, hydrogeneration. We know that it seems like hydro means that there's going to be an OH, but it's not. It's going to be two H's, hydrogeneration, H2. We add an H, we add an H. Remember here, the H2PD is going to be a hydrogeneration where we add two H's. Up here, if we have the Cl, it's going to be boronation. H2 over P, that's hydro, adding two H's, hydrogeneration. Generations, you have multiple generations, so you're adding two things. Oxymercuration, demercuration. Okay, this is what we're adding. We know that. Here, remember, we're always adding two things. So we're adding an OH and an H. Actually, you could tell that this is drawn incorrectly because that H should be down here where that double bond is. So this is actually incorrect. It should be down here. Technically, there'd be an H here, an H here, H here, and H here. This is Mark's rule. The OH is going on the carbon, the tertiary carbon. 1, 2, 3, tertiary carbon. So this is Mark's rule. If it went right here, well, I guess if it went right here, then it would be anti-Mark's rule, or what's considered non-Mark's rule. Okay, moving on. So we have hydration of alkenes, addition of H2O by hydroboronation. So what you need to remember is this is hydroboronation. When we're bored, so we can't make the effort to go on like this is the secondary carbon. This would be, oh wait, this would be 1, 2, 3. So this would be a tertiary carbon, but we're bored, so we're only going on the second carbon. We're so bored we can't make it over there. So BH3 is going to be boronation. Boronation, BH3. Boronation, BH3. Boronation, BH3. Non-Mark's rule. So we're going to put the OH on this carbon over here because we're bored. Okay, we're not going to go over here. Again, we're adding two things. We're adding an OH. We're adding an H. Moving on to oxidation. This is a, right here, this is showing that it's a carbonyl compound. So let me show what a carbonyl compound is. That's the carbonyl compound right there. So as you can see, carbonyl compound. So here, you would cut here when you have O3. O3 oxidizes. You have zinc. O3 oxidizes. So when it oxidizes, it cuts through here and here. Okay. Moving on. Halohydrins. Halo, of course, that can be Br, Cl, what's the rule? It's F, Br, I, and Cl. So they always use Cl and Br. So halo, Br, hydrogens over here. Remember, we're always going to add two things. So we're going to add a Br, an OH, halohydrin, Br, OH, Br, OH, halohydrins, halohydrins, halohydrins. The only one that I think is really going to trip you up because it's doing the same thing is over here. It's two of a kind. So there you have it. So remember here, I guess you can remember here, peed. They peed, so it's the same. Okay, you can remember when you go peed, it's number one. Number one, it's one type. That's how you can remember that. Peed, it's number one type. Over here, it's two types. So, halo, hydrin, halo, hydrin, halo, hydrin. Look at the reagent. Halohydrin, Br2 over H2O. Okay. Elimination, hydride and methyl shift. So there's going to be two, like we're showing here. So here, if it's HCl, it's going to be a methyl shift. So make sure you know how to do that methyl shift, which we do. And then if it's here, it's going to be a hydride shift. So the way I can remember it is they're acids. So up here, HCl is an acid, and acids will leave some sort of shift. It'll be a methyl shift. Over here, H2O, well, there's lots of H's, so let's go ahead and move another one over there in our acid shift and our hydride shift with H3O. Okay, elimination reactions. There's two kinds of elimination reactions. We have this reagent, which is going to normally, if you notice, we normally start off with a double bond and end up with a single bond. But here, we start off with a single and end up with a double, okay? Sometime in the test, there was a bond here, and the other one went here. Okay, so whatever it is, just add another one. So take it away. When you take it away, you close yourself off, and you'll add another bond. So here, with this type of reaction, it's always two things. So it's Br and H. KBr, H2O. KBr, H2O. KBr, H2O. In this next one right here, it's H2SO4OH. So how are we going to remember that? Well, in this case, we're going to remove the OH and the H, which winds up being H2O. So we're going to say, so that H2O, we're getting rid of it. So that H2O, we're going to get rid of it. So, that H2O, get rid of it. So H2O, get rid of it. When you get rid of it, you close your arm off. You close yourself off. Okay? Okay. So this is the 1,2-diol. And when we say hi to the 1,2-diol, we wind up, because remember, we're going to remove an H and an H. Hi, hey, diol. Hi, ho, it's off the dial we go. Hi ho, it's off the dial we go. And dial kind of sounds like a dial. Okay, so we're going to say hi ho, it's off the dial we go. So we're going to take the dial, we're going to hi ho it. And how are we going to do that? We're going to close it off and put, well, if you close that off together and put, where are we going to put? You can't knock the two H's together. So to form that double bond, so since you can't knock those two H's together, they kick out. So we're going to remove the outer part. So when we remove the outer, we're going to kick it out and add that double bond. So that's the way that we can write that. So HH, OO, let's go. And it kind of looks like I don't know, some sort of pretty jewel or a key, like a magic key almost. So just remember, hi, hotty ho, dio, it's off the way we go. The way I can remember is once we take away those H's, and we want a double bond here, right? But those O's would bang into each other. So when they bang into each other, they go sprung, and they'll go on the outside. So we can't close off those two H's because they'll go boing. So they'll go on the outside. Okay? All right. Hydroxylation. So I think the only thing that the teacher really wants us to remember is that this is an epoxy. She called it epoxy, was the short name for it. When you keep going with H2O, you get a diol. So I don't think it's necessary to remember this whole thing, so I'm not going to do it. I'm just going to remember that this is epoxy. Epoxylation. Okay, so next one. So we have a carbonyl compound. Well, the way I'm going to remember is we have this weird M&M reaction. M&Ms. And over here, this is what happens. Well, first, I want you to notice this H goes away and one of these H's go away. So when that happens, we have this nice little reaction. So I want some M&Ms. So let's drive with our car, because it's a carbonyl compound that has an O and an O, an O and an O, but it's cut through the H's, because we cut away an H and cut away an H. So let's put it on the end. So that OH is on the end. So I want some M&Ms. So let's drive with our car that has an O and an O. And remember, when it has an O and an O, we want a double bond. So let's cut through the H's so we can put an N to it. I think you should have already memorized these by now. Of course, we have 1,2 dihalide. These are 2 halides, 1,2 dihalide. We have a haliohydrin. This is a halide. This is an epoxy, alkane, we know that one. 1,2 diol, carbonyl compounds. Remember, the car has the M&Ms, and this is cyclopropane. So one thing that I want us to do is, what are all the things that have the H and H's? So the carbonyl compound gets rid of H and H's. What's something else that deals with H and H's? The diol compound deals with H and H's. And the hydrogenation does H and H's. Hydrogenation turns the dial. Hydrogenation turns the dial in the car. So we have a hydrogen that turns the dial in the car. Those all have H and H's. How about the car has a dial? No, I like the the hydrogeneration has the dial to turn the car. Or maybe when you get in the car, generations get in the car and turn the dial, kind of like in the radio, like if you're driving in the car. So like imagine you have your kids in the car. So those generations turn the dial in the car. So those three things are going to have the H and H's, okay? So the generations turn the dial in the car. That's how we're going to remember that. Okay, so let's do a quick recap. We have halo generations. Okay, we have the hydrogeneration. We have demercuration. Then we have the boronation, where we're so bored. Then we have the oxidation with the O3, because the ozone's so thin, it cuts through. There's a layer in the ozone. Then we have the halohydrons. Then we have the methyl shift with hydrochloric acid. Then we have H3O. Let's go! Moving the H and having a hydrogen shift. Then we have elimination reactions. Yay! We're removing H2O. We have 1,2 diol. Then we have the hydroxylation, where we're going to remember that's an epoxy reaction. Then the carbonyl compound, and finally the list of all of these that I hope you've remembered. Good luck!